Hi everyone, welcome back. This is part of my BESS Performance Engineering education series of videos. In a previous video, we looked into the different types of availability. In this video, we're going to focus on equipment availability. So first, we're going to look at kind of how to measure and compute equipment availability. Granularity means like how granular can we actually measure this availability? We can only do on and off. So if you had 10 strings, then you could only measure to 10%. The coverage is high because we can measure this for every intervals. Some other type of availability, like the operational, we can only assess it during operation of the BESS. The accuracy is very high. The signals that tells you if the string is connected or if the inverter is on or off, those signals are quite reliable. So we get quite an accurate representation. But the bigger problem is there's a bunch of blind spots. In this very simple example, you can see that this one battery string is empty. So there's one battery container. If it's not going to be able to be discharged. So eventually the BMS from that battery container will tell the PCS, stop discharging me. And then it will kind of stop being available. So equipment availability might not catch these conditions because every string is going to be connected. The PCS, every modules might be fully operational, but we're going to have some derating. So we're going to start with the battery strings, which is the more straightforward to measure. If the battery is connected to the inverter physically, like if the DC circuit is closed, so you always have as part of your BMS like an isolation contactor. If that contactor is closed, then your battery is connected to your PCS, and then the battery is deemed available. If you wanted to draw some current, it'll draw some current. So DC contactor status is a very reliable way to know if your string is available or not. BMS status are often based on this. They're also fairly reliable. If you don't have any of these measurements, or if you don't trust them, you could also measure the voltage of the bus and the voltage of the string. And if the contactor is closed, the voltage across contactor area is going to be very low. It should be 0, maybe just a tiny bit of ohmic losses. So you could actually compute the delta and detect if the contactor is open or closed. So in general, to compute the string availability in percent, you'll take the status of the contactor and the BMS status. You take the minimum of the two in case one is not accurate, and then that will give you your string availability. This number is going to be in percent or in ratio 0 to 1. For PCS, it's a bit more difficult to just use simple kind of contactor status because the power modules are controlled by the PCS controller. And even though DC contactors might be closed and powering the DC modules, if the DC modules are not running, if the IGBTs are not getting triggered, then you're not available. So in general, for PCS, the one of the most reliable way to measure availability is would be something like a status from the inverter. If the PCS modules are running in standby, ready, there could be different status depending on your PCS. You would have to determine which one represent like available and which one represent not available. The PCS might also report an availability in percent. Some of these modules might be 2 sub-modules. So a PCS module can maybe run at 50%. So it'd be maybe 0, 50, 100, depending on the topology. And then you could verify some of this with the status of the contactors if you have access to them, or some voltages. You'll have to kind of explore which voltage you have access to. But if there's voltage at the power module, if you have no voltage, it's definitively not available. If you have voltage, it's kind of means it could be available. Now, if it's not running, it's not going to be available. A bit like the string, we're going to want to take the minimum of like the most significant statuses that we can find. Typically module, like the status of the PCS, so just the module status, and then if there's a reported availability. So it'll be kind of equipment specific to pick the right signals, but you could use any of this and then maybe use a combination of a couple and take the minimum of the two. So to look at the full plant, we're going to take an example here of a BESS with 4 PCS and 10 containers. And you can see the reason we choose this example is they're not all the same. Some blocks have 2 batteries. The PCS are configured actually with 2 independent DC bus because they have 2 modules. But some stations have 3 batteries, and because we cannot divide 3 in 2, these stations actually have a single DC bus. This is a pretty typical configuration of a plant. You might have some stations, maybe just a small number that are different, but there's always going to be stations that are not the same. Because of this scenario, because they're not all the same size, if this was off, the availability of the plant here is not really 75%, because this station here is not a quarter of the whole plant, because it has only 2 batteries. It's actually only 20%. So the overall availability here will be 80%, not 75%. So for this reason, we're going to convert everything to megawatt. The capacity of a string, the capacity of a PCS module, we'll normalize everything to a megawatt equivalent at the point of injection. And we'll normalize everything to that location. So PCS power, this is where our PCS is 2 megawatt modules. It's 2 megawatt at the PCS level. At the POI, it's a bit less. We're going to assume here 2% losses for like the transformer losses or feeder losses, maybe a generator step-up losses. So we're going to assume that each module in this 2 per PCS capable of 1.96 megawatts. That's the equivalent of the POI. And then for the strings, we know we have 45 megawatt hour of installed capacity. That's tested at the POI. This is the 50 megawatt hour DC, but with the losses, your DC to AC transformation losses, your transformer losses, everything up to the POI, your 50 megawatt hour on it become 45 megawatt hour. And that's typically something that's tested with a capacity test. So I'm going to take this, divide this into the number of strings. So we have 50 string on this side. So each string is 0.9 megawatt hour. Then we need to convert that to megawatt. So we're going to need to figure out what's the megawatt equivalent of that 0.9 megawatt hour string. So this is a 4-hour system. The nameplate is 10 megawatt, 40 megawatt hour. So we're going to assume that the C rate is 0.25. We're going to assume that to running at nameplate capacity, that string can run up to at 0.225 megawatts at the POI. And I think that's a good representation of the capability of that string. If you add all this 0.225 megawatts times 50 strings, you get to 11.5, I think, megawatt. That's kind of your installed capacity in megawatts. That's kind of representative of the 45 megawatt hour of installed capacity. Play around with this number, make sure they all make sense. Then now for each device, a string, a PCS, you have an equivalent megawatt. So we're gonna transform the status on off, or the availability we get from the BMS, the PCS, 0 to 100%. We're gonna convert them into megawatts. So we'll convert this to megawatts for each stations. So this example here in the top left corner, we have one module that's off here, and then the battery container attached to this bus and this PCS module is fully available. But because the PCS module is not available, that bus capability is going to be 0 megawatt hour. The other module is fully available, but the container attached to it is only 3 out of 5 strings connected. So it's only 60% available. So that's the 3 times 0.225 is 0.675 megawatts. So the overall capability of this one station is just the capability of those 3 strings, really. Another example here is like if we have one bus, we have full PCS capabilities, but only 2/3 of the string capability. We're going to default to the string capability as the limiting factor. That would be the capacity of the old station here. This example here is a bit of an odd one, but this could happen where module is operational, but the containers attached to it are not, so that's 0. And on the other bus, the other half of the PCS, it's the opposite, where the PCS module is not available, but the battery is available. So that's also 0. Unlikely event, but it's possible. And then this highlights the fact that if you were to just look at the batteries and average this out as 50% available of the strings for this station, if you look at the PCS modules, 50% availability, 1 out of 2. But really, you can't just like take the minimum of the 2, add them up, like because they're actually connected to different bus. So this is why, in general, we're going to want to measure availability at the DC bus level, the physical connection of the batteries to the PCS. In this other example, we have pretty much all our battery except one string connected, quite a bit of DC capacity, but there's only one module running. So the limiting factor here is going to be the DC module. So then we add all this up, we'll get a megawatt number. And then this megawatt, we can convert it to percent, to contracted capacity and installed capacity in percent. So you get the installed capacity percent is always going to be a bit lower than contracted because installed capacity is always higher than contracted capacity. So to summarize how we calculate equipment availability, first of all, we're going to want to do the evaluation of the bus level for every interval. So for a bus index BI, we're gonna take the minimum of either the string availability in megawatt or the PCS module availability in megawatt, minimum of the 2 for that specific interval, which would be like 1 minute or 5 minutes. And then if we have no data, we'll assume it's 0. So if the station was totally offline and not reporting data, we'll assume that it was not running. Then for each interval, we still have the 1 minute interval. We'll sum up all these bus megawatts and we'll add the excused events. If you had 2 stations or if you have one PCS station that was under maintenance and that's excused, you're going to assume that it would have been 100% available. So we're going to re-add. You would track this into in a database with like the start time, end time, and the amount of nominal megawatts equivalent to how we calculated what a string is capable of. We're going to assume that if everything was operational, it would have been all the, let's say if it was 2 battery containers, all 10 strings would have been available. So then from the megawatt, you could reconvert everything to percent and percent of installed or percent of contracted. So you would take your BESS megawatts available, divide them by your installed capacity or your contracted capacity to get these 2 different percentage of availability. Now, this is still at the interval level, at the 1 minute level. So here we can make a nice time series chart of how your availability has evolved over time. From a KPI point of view, you want to track this probably at the weekly or monthly level or more. You're going to want to sum everything up. So you're going to sum up all these intervals and divide them by the number of intervals, and you will have your monthly availability. You're going to do this at the megawatts with the megawatt number, and then you'll reconvert the same way we did convert the interval values. You can convert that to percent of installed and percent of contracted capacity. The conversions of percent are pretty straightforward. The key things are measure this at the bus level. Everything needs to be normalized to megawatt. If there's no data, use 0. Then when you sum up everything to the best level, still at the interval granularity, add the excused events, the excused megawatts. So you get, if you had the loss of data, but you knew the equipment was up, you could create a custom like excused event, loss of data, that would bring everything back to 100%. The idea is like the number of intervals is always the same. If you have 1 month of 1 minute data, you're always going to divide by that number of interval. Even if like 30 days out of that month were excused, you would just add the megawatts for each interval that were excused to 200%. So excused are assumed to be 100%, no data, 0%. And then from there, you can easily recompute the percent. So in this video, we've covered equipment availability. And in the next video, we'll talk about operational availability. So stay tuned for more performance engineering insights.